All right, here we go. Let's dive into lesson 10, interpreting inequalities. Our first activity today is a true or false activity dealing with fractions and decimals. So let's see if we can figure these out. Is each equation true or false? And then explain our reasoning. Let's look at number 1. This looks like the distributive property, right? If I multiply 3 times 12, that actually matches that right there. And then if I multiply 3 times 5, which is what the distributive property says, that matches that right there. So I'm tempted to say, yes, this is a match. But I do see a problem. Have you found a problem? Here it is right here. This should be the sum of two products. But it's not. It's the product of two products. So this one is false. I needed a sum of two products. In other words, I needed to add together two things that were multiplied together. But they didn't. They multiplied them. So that's what made it false. Okay? Number 2. 1/3 times 3/4 equals 3/4 times 2/6. Okay, it looks like they just swapped the order of the 3/4. Here it was second and here it was first. But that's okay with multiplication, right? We know we can swap the order. That doesn't change the value. So the only thing we need to compare then is 1/3 and 2/6. Now at first glance, those do look different. But if you notice, 1/3 is actually a factor of 2/6. Because if I multiply 1/3 times 2, 3 times 2 is 6, and 1 times 2 is 2. So that's actually equivalent to that. So this one is actually true. We do actually have equivalent fractions in that product, so they are equivalent. Part 3, 2 times 1.5 times 12, and we're comparing that to 4 times 0.75, or 3/4, if you realize that's 3/4, times 6. Now, one of the first things I noticed is that all three numbers are different. So really we need to compare the total value, but we don't have to do math in order to do that. I noticed that 2 is half of 4, right? And that 1.5 and 7.75, this is actually half of that. But we kind of went the wrong direction. This is half of that, but this is half of that. So that's kind of the wrong direction. And this is actually also half of that. So I'm really leery here. I don't think these are going to be congruent or equivalent. I don't think they're going to be equivalent. But maybe we should do some math and find out. If I do the whole numbers here, 2 times 12, that's 24. 24 times 1.5. Now I could do that in my head. In fact, I already know it's 36. But even if I didn't know that, I would know it was more than 24 because it's 1.5 times itself, right? So that's more than 24. 4 times 6 here is 24. But if I multiply that by 3/4 or by 0.75, would I get something bigger or would I get something smaller? Yeah, you found it. I'd get something smaller, wouldn't I? 3/4 of 24 is actually, what, 16? Right? So yeah, those are definitely not equivalent, so this is false. 36 does not equal 16. Okay? Part 2, or activity number 2, talking about basketball now. Noah scored N points in a basketball game. What does 15 is less than N mean in the context of the basketball game? Okay, so if Noah scored N points, this is Noah's points. So 15 is less than Noah's points. So that means Noah scored more than 15 points. Does that make sense? If 15 was less than Noah's points, then Noah's points were more than 15. I just flipped that around, so it kind of made more sense in our context. Okay? See, and here's that other direction. I like this direction better. What does N is less than 25 mean in this context of the basketball game? Well, that means that Noah's points is less than 25. So Noah scored less than 25 points. So there's our two statements. He scored more than 15 points, but he scored less than 25 points. Okay, so the next thing it asks us to do in number 2 is to draw two number lines that represent the solutions of these two different statements we just said. Noah scored more than 15 points and Noah scored less than 25 points. So we're going to draw two different number lines here. So here's one for number 1. 0 is going to be my left-hand point here because I need to get all the way to 15, if not to 25, so that I can compare the two. So I'm going to go ahead and make a bunch of tick marks, and I'm actually going to count by 5s. I just want to have plenty so that I can compare. Okay? And then I'm going to do number 2 right below it. So I'm going to actually draw a very similar number line to the one I have above. Just so that, again, I can compare when I'm done. Okay, there we go. Now, for our first number line, we want to represent number 1, which is Noah scored more than 15 points, or 15 is less than n, if you remember our original inequality here. So 15 is the number, and we don't equal 15 because it's more than 15, so I'm going to put an open circle at 15. But Noah scored more than that. 15 was the lowest, right? 15 is less than his score, so I'm going to go to the right on this one. So I'm going to make this nice and dark and thick so that I can really see it on my number line. Then I'm going to make a nice big arrow. So Noah scored more. Well, I kind of got crazy there, but that's okay. More than 15 points. Okay, so that's number 1. For number 2, it says that Noah scored less than 25. Okay, so if it's less than 25, that's the point where we want to put our open circle because it's less than 25. It doesn't equal 25, but it is less than that. So because it is less than, this time I have to go to the left. Less than, of course, goes towards 0 in this case. So a nice big arrow there. All right, so if we compare these two, I've got Noah scored more than 15 points and Noah scored less than 25 points. Okay, so there's those graphs ready to go. Let's continue on with number 4 now. I kind of want to be able to see my graphs as I continue on here. Hopefully we can. I think we're okay if I go up a little bit higher here. All right, number 4, name a possible value for n that is a solution to both inequalities. And this is why I really like drawing my graphs very similar to each other because it makes this comparison way easier. If you notice, in order to be a solution of both, it has to be somewhere in between 15 and 25. Do we see that? In order for it to be both, I have to be right in here somewhere. So name a possible value. Well, 20 is a possible value. N could equal 20, but it doesn't have to be 20. N could be 22, right? 22 is greater than 15 and 22 is less than 25. So there's a whole lot of solutions that would actually work for that. So we've named 2. Number 5, name a possible value for n that is a solution to the first one, but not a solution to this one. Okay, so we want something that is on this arrow, but is not on this one. So that looks like we're gonna have to go up into this range, aren't we? How about 30? Can n be equal to 30? Well, if it is, then it is on this arrow, but it's not on this arrow. So that actually is true for this statement, isn't it? Is there another value? Sure. N could be, how about 34? 34 is on this arrow, but it's not on this one, right? So n equals 34 is another possible value, okay? Number 6, can -8 be a solution to n in this context? And here's the important phrase here, in this context. Remember, n is a number of points in a basketball game. Can the number of points in a basketball game be -8? Well, according to this graph, it does keep going into the negatives, but does it really in this context? I would say no. There's no negative points in basketball, right? There's no such thing as negative points in basketball. We don't even take points away, really, in basketball. You earn them or you don't, right? Awesome. So that's activity number 2. Activity number 3, I think, is my favorite because if you remember back in the day when we did hangers, it's one of my favorite things to look at is these balanced, or in this case, unbalanced hangers. So let's take a look at these and how they compare to inequalities. It says, here's a diagram of an unbalanced hanger. Jada says that the weight of one circle is greater than the weight of one pentagon. Okay, so here's our circle and here's our pentagon. Definitely looks like the circle is greater. It's weighing heavier, isn't it? So that makes complete sense to me, Jada. I think you're right. This circle weighs more than the pentagon. And that's what she said, so I agree with that. Write an inequality to represent her statement. Let P be the weight of one pentagon. Okay, so we're going to use P for pentagon and C be the weight of one circle. Makes complete sense. P for pentagon, C for circle. Okay, well, if that's the case, then P is less than C. Does that make sense? The weight of the pentagon is less than the weight of the circle. Now, that's not the only inequality we could write. We could also say that the weight of a circle is greater than the weight of the pentagon. We could flip those around. As long as we flip the sign as well, we can flip the variables. Okay, so those are our 2 possibilities for part A. Part B. A circle weighs 12 ounces. Okay, so now they give us one of the values. The circle is 12 ounces. Use this information to write another inequality to represent the relationship of the weights. Then describe what this inequality means in the context. Well, basically, we know one of these values, so we no longer need to use the variable C. So all I have to do is plug 12 in for C, and I'm done. P is less than 12, or 12 is greater than P. Okay, so we did the substitution now. What does it mean? Describe this inequality and what it means. Well, that means that the pentagon weighs less than 12 ounces. Does that make sense? Because that's literally what that says. If the circle weighs 12 and the pentagon is less than the circle, then the pentagon must be less than 12 ounces. Okay. This side means that 12 ounces is greater than the weight of the pentagon, which is basically the exact same thing. We just switched the words around, didn't we? Okay, so either one of those would be correct. Okay, let's move on to the next question, number 2. Now, number 2 says, here's another diagram. Oh, maybe we don't need those anymore. Maybe I'll get that out of our way. Here's another diagram of an unbalanced hanger. Okay, so this time we have a square and a pentagon. It says, write an inequality to represent the relationships of the weights. Let P be the weight of the pentagon. Okay, so the pentagon again is P. And S to be the weight of one square. That completely makes sense. All right, so we need an inequality. Looking at our unbalanced hanger, it looks like P is heavier, right? It weighs more. So we could say that S is less than P. The weight of a square is less than the weight of a pentagon. Or we could switch it all around and say that means that a pentagon weighs more than a square. Again, a pentagon weighs more than a square. Okay, so there's 2 possible inequalities we could write for that. In part B, it says that one pentagon weighs 8 ounces. Okay, so once again, now I know one of my values. Pentagon now equals 8 ounces, so I could substitute that in every time I see my P. Okay, so S then would be less than 8, or 8 is greater than S. Now describe that inequality and what it means. Well, that means that the square weighs less than 8 ounces, or 8 ounces is more than the weight of the square. Okay, so either way of describing that is just fine as long as you have your numbers and symbols swapped. Okay, now in part C it asks us to graph these inequalities on a number line. So let's graph them. Now they're going to be just one graph because really they are the same thing, aren't they? All right, so if S is less than 8, I'm going to have 8 on here. So let's put 0. Should we count by 2s? 2, 4, 6, 8, 10, 12, 14. Okay. And S is less than 8, so we're going to have an open circle at 8 because it's less than that. It's not equal to it. It's less than, so it's open. But then less than means to the left of. So I'm going to turn this so that my shading is a little better than it was last time. I'm going to shade to the left, and I'm going to make a nice solid arrow to mean that can keep going. Okay, so there's my graph of this solution. Now, does it still match this one? Is 8 still greater than S? Yes, because S is my arrow, isn't it? And 8 is bigger than the arrow. So that still works. Either one of those match. Okay? Number 3, based on your work so far, can you tell the relationship between the weight of a square and the weight of a circle? Well, what do we know? Maybe we do need to go back to the last activity. What do we know about... Ooh, wrong page. What do we know about the circle? Well, we know that the circle is 12 ounces, right? We got that from number 1 here. The circle weighs 12 ounces. What else do we know? We know the pentagon is 8 ounces. Do we know the square? Nope. We don't know the weight of the square. But we're asked to compare the square to the circle. What do we know about the square compared to the pentagon? Well, we know that the square is less than the pentagon. So the square is less than the pentagon. But the pentagon was less than the circle. But the pentagon was less than the circle. So let's look at what we know. The square is less than 8, right? The square is less than the pentagon, which is 8. But the pentagon is less than the circle, which is 12. So 8 is less than 12. Well, we'll say that the pentagon is less than 12. Or the square. Yeah, the pentagon. So what I'm thinking is that that pentagon is somewhere between 8 and 12. Now I've got a whole lot of gibberish written here, and I'm going to organize my work a little bit. I'm going to go back to saying, okay, this is actually making a little bit more sense to me. The square is less than the pentagon. The pentagon is less than the circle. So is the square less than the pentagon, which is less than the circle? That's kind of a funny way to write it. That's called a compound inequality. We haven't seen those a whole lot, but literally that shows us that the pentagon is in the middle of the square, which we don't know how big it is, and the circle, which is 12, right? And the pentagon, we know, is 8. So what do we know about the square? We know that the square is less than the pentagon. Pentagon is less than the circle, so the square must be less than the circle, right? That's what it's asking here. Can you tell the relationship between the weight of a square and the weight of a circle? Yes. The square must be less than the circle because it's even in less than the pentagon, isn't it? the square weighs less than the circle. And there's our answer for number 3. Okay? Now we're ready for number 4, another unbalanced hanger. Here we go, number 4. This is another diagram of an unbalanced hanger. Andre writes the following inequality. C plus P, circle plus pentagon, I'm sure that's what that stands for. The weight of the circle plus the weight of the pentagon is less than the weight of the square. Do you agree with this inequality? Explain your reasoning. Okay, C plus P, the weight of the circle plus the weight of the pentagon. That looks like this side, doesn't it? The weight of the circle plus the weight of the pentagon is less than the square. Does that make sense? Circle, pentagon, square. Is this less than this? That's where I think it goes wrong. Because that means this unbalanced side, this is the heavier side, isn't it? Which means that this sum here is actually greater than the square. So I'm going to say no. C plus P is actually greater than S, right? It's heavier. Okay, number 5. Jada looks at another diagram of an unbalanced hanger and writes S plus C is greater than 2T, where T represents the weight of one triangle. Draw a sketch of this diagram. Okay, greater than. So S plus C, square plus circle. So very similar to this, we're going to have 2 shapes on one side, okay? And that's greater than. So again, heavier means that that's going to be the lower end. Okay, so I'm going to draw my hanger to match that. And I'm going to have the low end and the high end up there. And on my heavier end, I need to have S and C. I need to have a square and a circle. I'm going to go ahead and fill those in because that's what they did. So I have a square and a circle on the heavier side. And what do I have on the lighter side? Well, I have 2 triangles. 2 triangles. Okay. So a square plus a circle's weights are heavier than the weight of 2 triangles. There's my sketch. Do you agree with that? Good job, good job. Oh, and guess what? That's the end of our lesson. The only thing we have left here is our Are You Ready for More? This is optional. But honor students, again, this is a really great one. You're looking at another balanced hanger this time and coming up with some answers to these questions. I bet honor students, you for sure can handle this one. So I would challenge you to that. Make sure you please read through the summary pages so that you are fully ready to dive into the practice problems which are coming up next. I know you can do it. Do it on your own first, don't forget. And as always,
do your best because you deserve your best.
Alrighty, you have hopefully finished your practice problems for lesson 10 and are now ready to go over the answers along with me. So let's dive in. Number 1 says there is a closed carton of eggs in my refrigerator. The carton contains E eggs and it can hold 12 eggs. Okay, so this is a dozen carton of eggs. Okay, part A. What does the inequality E is less than 12 mean in this context? Well, if E is the number of eggs in the container, then the number of eggs in the container is less than 12. So this means that the container is not full. It does not have 12 eggs in it. The container is not full less than 12 eggs, right? It's not full. There's not 12 eggs in it, or else if it had 12, then it would be full, right? What does the inequality E is greater than 0 mean in this context? Well, E is the number of eggs in the container. So if the number of eggs in the carton, I said container, but it's carton of eggs. The number of eggs in the carton is greater than 0. Well, that means the carton is not empty, right? There's at least one egg in there. E is greater than 0, right? So it's not completely empty. There's at least one egg, so more than 0 eggs. Okay? What are some possible values of E that make both of those inequalities true? Well, if we know there's fewer than full and we know there's more than empty, then E could be, there could be 2 eggs in there. Well, there could be 6 eggs in there. There could be 8 eggs in there. As long as there's not 0 and there's not 12, it could be anything in between, right? So there's lots of different possibilities for that one. Number 2, my favorite, the balanced hangers. Write an inequality to represent the relationship of the weights. Use S to represent the weight of a square. Okay, so the square is S in grams, and C to represent the weight of the circle. So there's our circle in grams. Okay, so we need to write an inequality. Well, it looks to me like, according to this hanger, C is heavier. The circle is heavier than the square. So to write that as an inequality, we're going to write C is greater than S. The circle weighs more than the square. Now, could I write it the other direction? Certainly I could. I could write the square weighs less than the circle. Does that make sense? Either one of those is totally fine. Okay, part B. 1 red circle equals 12 grams. Oh, so the circle equals 12 grams. We know that now. Write an inequality to represent the weight of 1 blue square. Okay, so now we want the square. So we're actually going to steal from this one because we want to compare it to the square. So the square is less than the circle, and the circle equals 12, so the square is less than 12. There's my answer. Now, could I have used this one? Absolutely. It would have just been 12 is greater than the square. Either one. Okay? Could 0 be the value of S? Well, is 0 less than 12? Yes. Mathematically, that makes sense. So, yes is not a wrong answer. Because yes, 0 is less than 12. But in this context, can the square weigh nothing? Well, I say if something exists, then it has weight, right? The square has to have some kind of weight. So I will take yes or no on this one as long as you explained your reasoning. Yes, because mathematically 0 is less than 12. No, because contextually the square needs to weigh something, even if it's just 0.001, something really small. There's argument for both sides. Okay, so I'll let you explain your reasoning on that one. Moving down to number 3 now. Tyler has more than $10. Elena has more money than Tyler. Mai has more money than Elena. Oh, goodness, we're going to have to jot some notes down to keep track of all that. Let T be the amount of money that Tyler has. Okay, so T is Tyler. That makes sense. So T is Tyler. Tyler's money. E is the amount of money that Elena have. Okay, so E is Elena's money. And M is the amount of money that Mai has. So M is Mai's money. Okay, so we got to keep those track of all of those. Now, what else do we know about this money? We know that Tyler has more than $10. So T is greater than 10. Do we agree with that? Tyler has more than $10. Tyler's money is greater than $10. Check. Okay. Elena has more than Tyler. So Elena has more than Tyler. Oh, okay. Check. Mai has more money than Elena. So Mai has more money than Elena. Oh, I'm seeing a pattern here. Mai has more money than Elena. Okay. Now, our job. Select all statements that are true. Okay. Is Tyler's money less than, what's J? Maya has more money than T is the amount. Tyler, E is the amount of money that Elena has, and M is the amount of money that Maya has. Select all that are true. Is this a typo? Where the heck did J come from? My goodness. I don't know where J comes from. So we're going to throw it out. There's no such thing as J, so I'm going to throw that one out. Okay, let's go on to B. M, or Maya's money, is greater than $10. Is that true? Well, Maya has more than Elena, and Elena has more than Tyler, and Tyler has more than $10. So yeah, I'm thinking Maya must have more than Ty, or more than 10, because she has more than Elena, Elena has more than him, and he has more than 10. So yes, following the chain back, Maya has more than $10. That is true. Does Elena have more than $10? Well, I think that's also true because Elena has more than Tyler, and Tyler does have more than 10. So I think Elena will have more than 10. Does Tyler have more than 10? That was our very first thing. Tyler has more than 10. So yes, Tyler has more than 10. Does Elena have more than Mai? Does Elena have more than Mai? Well, Elena has more than Tyler. Oh, actually, it says that Mai has more than Elena. So this is backwards, isn't it? Mai has more than Elena. So Elena does not have more than Mai. That end's gone. Okay. Last one. Does Tyler have less than Elena? Well, Tyler has more than $10, and Elena has more than Tyler. There's the key right there. Elena has more than Tyler. So does Tyler have less than Elena? Yep, so if you go backwards and flip the sign, Tyler has less than Elena. So yes, Tyler has less than Elena. So my answers are B, C, D, and F. B, C, D, and F. And again, I don't know where that J came from, so I'm going to have to look into that into my solution manual, but I think that might be a typo. Okay? Very, very good. Moving on to problem number 4 now. Jada is taller than Diego. Diego is 54 inches tall, or in other words, 4 feet and 6 inches tall. Write an inequality that compares Jada's height in inches, J, to Diego's height. Okay. So Jada is taller than Diego. I'm going to change that into an inequality. Jada is J is taller than Diego, D. Does that make sense to everybody? I think that's true. Jada is taller than Diego. But I know that Diego is 54. So wouldn't Jada have to be therefore taller than 54 inches? Yeah, I think that must be our inequality, right? Inequality compares Jada's height in inches to J to Diego's height. Well, yeah, Diego's height is 54, so there it is right there. There's part A. Jada is taller than 54 inches. Okay. Jada is shorter than Elena, and Elena is 5 feet tall. Write an inequality that compares Jada's height in inches, using the, again, the letter J, to Elena's height. Well, Elena is 5 feet tall. Now, in inches, 5 feet is 60 inches, right? Because 12 inches is 1 foot, 12 times 5 is 60, okay? So Elena is 60 inches, and we want to compare Jada to that. Well, Jada is shorter than Elena. So Jada is shorter than Elena. And if Elena is 60, then Jada is shorter than 60. There's part B's. Jada is shorter than 60 inches, or less than. Very good. That was number 4. Number 5. Which is greater, -9/20 or -0.5? Now these are really hard to compare when they're both written as when they're written as a fraction and a decimal. It'd be easier as if they were either both decimals or both fractions, right? Now I'm tempted to go to the fraction route because I know that 1/2 can be written in lots of different ways. 0.5 is 1/2. So if I have -9/20 and I'm trying to compare it to a -1/2, can I change this to look more like this? Yeah, I could. 2 goes into 20 10 times. So this would be equivalent to 20, right? 2 times 10 is 20. 1 times 10 is 10. So this is negative 9 tenths. So now I'm comparing negative 9 twentieths to negative 10 twentieths. And that is equivalent to that. Does that make sense to everybody? So which one is greater? In other words, which one is closest to the right, closest to 0? Well, if I go down to negative 9 twentieths, and then I go to negative 10 twentieths, don't I go further away if I go to negative 10 than if I go to negative 9? Yep, you do. So I think my final answer is negative 9 twentieths is greater. There's my final answer. Number 6, select all the expressions that are equivalent to 1/2 cubed. All right, well, we have to remember, what does this exponent mean? Well, it means that we take whatever it is to the power of that base times itself 3 times, right? So this is 1/2 times 1/2 times 1/2. Oh, look at that. That's exactly what part A says. So A is definitely part of our answer. All right. Now, is that the same thing as B? Well, 1 times 1 times 1 is still 1. And 2 multiplied by itself 3 times is exactly what I have on the bottom. 2 times 2 times 2 is the same thing as 2 cubed. So yes, B is also true. Now looking at C, do you notice the difference here? If we compare this directly with this, they swapped the 2 and the 3. Is that allowed? Well, let's see. We know this is 1/2 times 1/2 times 1/2. This one would be 1/3 times 1/3. 1/3 twice. This equals 1/8, and this equals 1/9. 3 times 3 is 9. So that's definitely not equivalent. Now we know that we just found that this right here equals 1/8, so it's definitely not 1/6. Oh, but look at that, but it is 1/8. We just found that out, so E is also an answer. So the answers to number 6 are A, B, and E. There we have it, ladies and gentlemen. We are done with our homework for lesson 11. Congratulations, you've been working, or not lesson 11, lesson 10. My apologies, lesson 10's homework. Well done, you've been working hard. Keep going. Next is your Check Your Understanding quiz. Hopefully you feel confident and able to do that one. So dive into that, and I know you can do it. As always,
do your best because you deserve your best.